Hi all, welcome to the review for Unit 11, Coordinate Geometry. Please make sure you're done with lessons 1 through 8 before you start with this review. Also, try to upload all your independent practices onto the Canvas website if you have not done so far. Please print this packet also, and if you do not have access to a printer, just copy the questions on a separate sheet in your notes, and also find a ruler if you can to sketch out all the graphs, because it will be very easy for you that way. Okay, so let's get started with the first question. It says triangle ABC has vertices A, B, and C. So the coordinates are given. If you've noticed, the coordinate for A is x comma 3. So the first coordinate is always your x coordinate, and the second coordinate is your y, which is 3. So if you think about it, if my y is 3, y equals 3 is this line, right? I'm just going to sketch it here. This is the y-axis, y equals 3 will be this line, right? So my point will be somewhere on this line. I don't know my x coordinate, but since my y is 3, it's going to be on this line. So that kind of approximates you or gives you an idea of where your point would be. Now it says determine and state a value of x. So we want to find a x that would make this triangle ABC a right triangle. So again, right triangle means the lines are going to be perpendicular, and the slopes are, how do I find perpendicular lines? Negative reciprocal slopes, right? So justify why ABC is a right triangle. Justify means show work. That's what justification means, show work. So this word justify means show work, okay? So I already have the T-chart set up with my sides of the triangle. So I want to find the slopes, because we are trying to prove that the lines are perpendicular so that the triangle is a right triangle. So what's the slope of BC? Again, read your line from left to right, right? Or trace it. It is going down, so the slope is going to be negative. And how much? It's rise over run, right? So it's down 3 over 2. So it's negative 3 over 2. Any line that's perpendicular to this line will have what? A slope which is a negative reciprocal. So what's negative reciprocal of this? Of anything opposite of negative is positive, and you flip the fraction, so it's going to be 2 over 3. So basically from B, I am going to start plotting this point. I'm going to go up 2 over 3. So up 2 over 3. Would that be my point A? No, because I know it is going to be on the green line. So I'm going to keep going till I hit the green line. So up 2 over 3. And look, I am on my green line. This point is 3 comma 3, right? Because my y coordinate, which I always know was 3, my x is this point. So this is my point A. I'm just going to use this marker and freehand, and this is my point A. So what were the coordinates of your A? It is 3 comma 3. So let's fill that in. That's 3 comma 3. Okay, so now triangle DAN is graphed on the set of axes. The vertices of triangle DAN have coordinates. They're given to you, which are already plotted. It says determine the area of triangle DAN. So we basically want to determine the area of this shaded region, like if I was to shade this or this triangle, right? How do I find that? Okay, since these are not straight lines, like what's the formula for the area of a triangle? It's base times height. If you look at the base, it's not a straight line, so can't really help with that. So if we draw a rectangle around it, if you think about this, I'm just going to highlight it with the green and see, isn't this a rectangle? If I find the area of this rectangle in green and subtract the sum of these 3 triangles that I built around it, triangles 1, 2, and 3, I will be left with what? Area of the given triangle. So I already filled in the formulas. So area of a rectangle is length times width. So what's my length? My length is 11. 11 times 12, right? Which is 130. 32 square units. Okay, so now similarly, I'm going to find the area of each triangle. I drew the triangles around. What is this length? This length is 11 and this is 3. So it's going to be 1/2 11 times 3. So which is 33 over 2, which is 16.5. The next one is, what is my length across? It is 9 and this is 7. You can just count the boxes. All I'm doing is counting the boxes. So let's put it in 1/2 times 9 times 7, which is 63 over 2, which is 31.5. And the last one is 1/2. What is this length? This length is 12 and this is 4. All right, so it's 1/2 times base is 12 times 4, which is 24, right? 48 over 2, which is 24 square units. So you have your 3 triangles. If I add these up, I get what? 16.5. Hold on. So it's basically, if I add these up, I get what? 16.5 plus 31.5 plus 24 is 72. So that's 72. So what do we know? How do we find the area of the triangle? Let's write it down. Area of triangle, DAN, is equal to area of rectangle minus 3 triangles, right? So area of rectangle was 132 minus 72 is 60 units square. Okay, so now let's try the next question. It tells me that quadrilateral ABCD has vertices, and I already plotted them. And now it's asking me to prove that the quadrilateral is a parallelogram. What do you know about the parallelogram? How do you prove if any quadrilateral is a parallelogram? If you prove that both pair of opposite sides are parallel. If they're parallel means what? They will have what kind of slopes? So let's think. Same slopes, right? So let's find out the slopes of all these different sides. So the slope of AB is, first of all, look at the line. It's going up. So rise over run. So what's my rise? My rise is 5 and my run is 4. 5 over 4. Slope of BC. First of all, my line is going down, so it's going to be negative, and it is what? BC is, it's going 4 down 4 over 5, and then CD is again a positive line. That is 5 over 4, rise over run. I'm literally counting the boxes, right? And the last one is DA or AD. It's again line going down, right? If anyone is confused with that, we talked about it in our previous lessons. Look at this. If I trace my line from left to right, I'm going down, right? So that's why I said it's going down. It is going to be a negative slope, and it is what? 4 over 5. So what do I know? Look at these slopes. I'm just going to take this. Look at these. They have same slopes, and these two have same slopes, right? So what can I say? Same slopes, right? Let's write that down. Same slopes for both of them. So what can I say? ABCD is a parallelogram. Literally the same definition that we were trying to prove, used to prove that they are parallel. ABCD is a parallelogram because both pairs, you have to prove both pairs, not one pair, both pairs of opposite sides are parallel, right? Okay, So the next one is prove that the quadrilateral ABCD is a rectangle. Again, go back to your notes if you don't remember. How do you prove anything is a rectangle? You want to prove all angles are 90 degrees. Like these angles are 90 degrees. Okay, whenever we talk about 90 degrees, what are we talking about? These means these are perpendicular lines and means their slopes are going to be negative reciprocals. So look at this. I'm just going to highlight them actually in a different color, in purple maybe. Look at this. This is 5 over 4 and this is negative 4 over 5. So adjacent lines are what? Perpendicular because their slopes are negative reciprocals of each other. So let's write it down. ABCD. So you didn't even have to do any work for it. It was already done for you in the previous question. ABCD is a rectangle. Again, you had to know the definitions, because if you did not know how to prove it, then it was all in vain, because all 4 angles are right angles. What told us 4 angles are right angles? Because what did we do? How did we use the slope to manipulate that? Because negative reciprocal slopes, what happens if you have negative? Sure. Perpendicular. You have to write that, please. Perpendicular. I've spelled it wrong. Perpendicular lines which form right angles, right? So if you look at any two pairs of adjacent sides, their slopes of negative are negative reciprocals. So that is it. So it was more of writing in this question than actually doing the work. The work was pretty basic, right? With all these coordinate geometry proofs, you're either doing lengths or you're doing slopes, and you're just interpreting those. So keep doing that. Okay. Again, know your vocab. It says two lines have the same y-intercept. Think about y equals mx plus b. Your b is your y-intercept. Are perpendicular means what? That the slopes are negative reciprocals, right? Perpendicular lines, negative reciprocal slopes. If the equation of one of these lines is this, determine the equation of the second line. So we know the equation of the first line is this. First of all, it's not in standard form. So let's write it in standard form. So I'm going to rewrite the equation. You want y by itself, so I'm going to divide each by 5. So I'm getting what? 3/5 x minus 2, right? That's my m and that's my b, right? So if this was my m and you know that the other line is perpendicular, so that my new m would be what? Flip it and negate it. So 5 over 3. My new m will be, I'm going to call this m1 and this I will be m2, equation of the second line, right? And it has the same b. So the b is what? Negative 2, because it said same y-intercept. So now, once we know this, right, and this, we can write down our equation. So our equation is y equals negative 5 over 3 x minus 2. So that is the equation of the second line with the same y-intercept, negative 2, but they are perpendicular. Okay, so